When we talk about memes, what is the first thought that comes to your mind? In the 70s, memes were defined as a type of cultural gene capable of transmitting culture, beliefs, and behaviors, and suffering some variations, selections, and retentions along their existence. Nowadays, millions of memes are shared every second. I'm sure you remember that funny image, gif, or video that you saw on the internet. But they are not always funny. Studies show that memes are being largely used to spread hate speeches against groups of people, based on their ethnicity, religion, gender identity, sexual orientation, disability, and many more. To tackle this problem, AI can help us by identifying the bad from the good ones, analyzing both image and text. So Facebook launched a contest, the Hateful Memes competition, where your model must identify those direct and indirect attacks, and its performance is measured by its accuracy and AUC score obtained. The dataset provided has 10,000 samples, and is composed of 3 files: train, the validation, and test, all of them being unbalanced. The test file is provided unlabeled because it is the one that the competition uses for the model's evaluations. In the phase 2 of this competition, there were added more files in order to extend the dataset. The images are labeled as either hateful or non-hateful, and the memes can be of the following types: multimodal hate, unimodal hate, benign text confounder, benign image confounder, and random non-hateful. Additionally, there exist some memes with the same text with different images, which make them change their objective. As an example, this meme changes its meaning with just a change of its image. The memes that compose this dataset present protected categories, like ethnicity, religion, and sexual orientation, which are used to attack people, mainly through dehumanization, comparing them to animals or objects. For this project, we used the Transformers library, based on PyTorch and the Keras framework, to create the text and image models, respectively. We also used the sklearn classifiers, and all the experiments were performed on Google Colab. First, we tried with image in painting to remove text, but it didn't work, so we just worked with the original data. In order to create the baseline, we performed some experiments. We tried with the text and the image models alone. After that, we combined them using a weighted mean of their probability outputs with some combinations of weights. To process the text, we trained a BERT model transformer with a linear layer on top of the pulled output. And to process the image, we trained a ResNet50 classifier with one sigmoid neuron in the output. We also experimented with using those classifiers as feature extractors and combined the generated features to evaluate in some sklearn model. For the final solution, we decided to perform some pre-processing steps, aiming to help the models in their learning process. Some of them were to elimination, L punctuation and only repeated punctuation, reduce elongated words, and eliminate text areas from the images by removing whole rows containing words. Besides that, we built feature extractors from the image and text models, concatenated the generated features, and experimented with some sklearn classifiers. At last, we experimented with a multimodal model pre-trained on the data from the competition, which is provided in the MMF framework. In the table, we can see the results for our approaches. As we can see, the best result was obtained by BERT model with 73%. This shows that the text for this problem can be more informative than the images, and that better approaches to deal with both need to be experimented.